and continuous wave and also color Doppler system. Beam profile, slide thickness phantom. The slide thickness phantom is to measure the dimension of the beam. Remember, the beam have 3 dimensions, and the lateral and elevational resolution are hard to measure, and we are using the beam profile slide thickness to know what are the thickness of the beam. Remember, lateral resolution depends on the thickness of the beam, and remember that elevational resolution, when it's too big, produce artifacts. Increased slide thickness will diminish the spatial resolution and reduce the ability to distinguish small or low contrast lesions. When the ultrasound beam is too thick, cystic structure may appear like filled in. This kind of slide thickness phantom are more used in the factories where ultrasound was produced. Measuring the output of the ultrasound machine in what is very important, because that lets you know that the machine is safe. Really, measure or quality assurance are very important, but it's not the sonographer that measures the output of one ultrasound probe. This is more about technicians, engineers, and factories that produce ultrasound machines. Typical distack is for manufacturer and not for technicians. Hydrophone is a little probe less than 1 millimeter diameter with a piezoelectrical crystal at its end. The dimensions of the hydrophone are so small that the sound beam is essentially undisturbed. Acoustic optics are based on the interaction between 2 types of waves, sound and light. A shadow system called Schierling uses this principle to measure the beam profile. A calorimeter is a transducer that converts acoustic energy into heat. When ultrasound beam is in the calorimeter, the energy is absorbed, and that lets measure the quantity of heat produced by the ultrasound beam. When the temperature increase is measured, the total power of the ultrasound beam can be calculated. This is to be sure the ultrasound beam is safe. A thermocouple is similar. It's a small device embedded in absorbing material. The sound is absorbed and converted into heat. The ultrasound intensity at a specific location in space is measured by the thermocouple. Ultrasound system can be evaluated for deep accuracy, deep sound, linearity, axial and lateral resolution, and position registration. Minimum sensitivity is the little gain that you need to visualize a pin located deep in the test object. Normal sensitivity is the gain setting to see all the pins in the test object. All other performance measurements are made with the normal sensitivity. When a tissue phantom is used, normal sensitivity establishes the maximum depth of tissue texture. With constant instrument setting, this depth should not change between evaluations. Registration accuracy is the ability of a B scanner to place echoes in the proper positions. Range accuracy. This is the deep calibration, allow assessment of the machine ability to accurate position echoes. If one error exists, it may be due to the matching malfunction or because the speed of the sound in the phantom is not the speed of the sound in soft tissue. Horizontal calibration is similar to vertical calibration, but is about lateral resolution, side by side. This zone is the minimum distance that the machine can see a structure. Focal zone is to determine if the focal areas are in the area that the machine tells you is. Longitudinal resolution is the smallest recorded distance between two pins in vertical. Lateral resolution is the minimum distance between two pins when you are in horizontal. Compensation is the uniformity, and that lets you know if the time gain compensation is working correctly. It's about attenuation. Phantom with mock cysts and tumors. By using a tissue equivalent phantom, you can know the dimension and the shape of cysts or solid mass, also the texture of the tissue. You can see here tumors and cysts in this phantom. Display and grayscale dynamic range. With any group of pins, you can know if the contrast of the machine is accurate and about if the grayscale is the same that you expect.